So welcome back to the second part of this tutorial series on the PCG framework. We will now start in an empty scene, set up an environment or landscape, bring in some height field that I created in Houdini, and also some masks to have different ground types like forest debris, fallen leaves, but also some grassland. And then we will take these different ground types into the PCG framework, sample them, and decide which kind of static meshes we want to spawn on them. And then we are going to create a forest environment using all of the techniques that we learned in the first part, and also going into more detail probably on some of these techniques. So let's start by creating a new level. Basic. Gonna call it PCG Forest Tutorial. And we don't need this floor. Gonna go into the landscape mode and choose the file that I'm providing, which is heightfieldterrain.r16. Choose it under height map file, and then we need to check some settings here. The height map resolution will be automatically set to 1009 by 1009, but we need to make sure to use sections per component one by one, because I found that the PCG landscape sampling or point filtering was causing some bugs in the 2x2 mode here. I think this will probably be fixed in future versions since it's still an experimental feature, but for now I found this to be a fix for this. So I'm also going to set the overall resolution to 1009 by 1009 and press import. I also set the scale on the z-axis to 20 because this provides the best results for the height field. Then what we're going to do is we are calling this layer base terrain and create another edit layer that I call layer masks. And then we're going to create a material. Call it mForest tutorial. In this material we are gonna create some basic landscape layers. So first of all I'm gonna create a landscape layer blend, and I'm gonna create 3 layers. First layer I'm gonna call base. The second layer I'm gonna call grassland. And the third layer I'm going to call cliffs. And also set the material to use material attributes. So just click into an empty space and tick this checkbox. And then connect these nodes. For now you're going to get some errors that we are now fixing. So first of all we're going to need a make material attributes node. And then we need to import some textures. I already downloaded some textures from Megascans. I have the dried leaves, mossy rocks, and wild grass. I'm going to provide all these asset IDs in the video description so you can follow along with the exact same textures. And all you need to do is then use the Quixel bridge and paste the asset ID here, or of course you can also just decide by yourself which kind of ground textures you would like to use. So then back in the material we need some texture sampler 2D parameters, and this one here I call base for layer base, and then base color, connect it to the base color. Then copy this parameter, I'm gonna call it base normal, and also set it to sampler type normal. Connect it to the normal. Put a default texture here also as a default normal texture. And then we need another node for the occlusion, roughness, and displacement map, but we're only going to use the roughness for now. So the roughness is on the green channel, so we're going to connect the green channel to the roughness of the material, and gonna call it ORD. And then what we also need is a landscape coordinates node and a value and a multiply. And we're just going to make this value a parameter. I'm going to call it base tiling and then connect it to all of these UV inputs. So this is the basic setup for one layer, and of course this is just like an extremely basic landscape layer material, just to have something on the landscape, to have some textures on it, and to also use them in the PCG framework. So I'm going to plug it into layer base, and then copy all these nodes and plug this into layer grass, and another copy and plug it into layer cliffs. And now I want to still change some things and clean up a bit. So I'm going to put all the tiling default parameters on 1. And then I'm going to change some names and put it into some groups. So here we are in the material setup for grassland. So I'm going to put grassland everywhere here. To the normal, into the ORD, and then put it also into the group grassland. Same here. And same here. Then also grassland tiling, put it into the group. And same for the base color. I didn't create, same for the base layer. I didn't create a group for the base yet, so I'm going to quickly do this. And then last for the cliffs. So this is cliffs base color and cliffs normal, cliffs ORD, and then also assign the groups. Save it, select it in the content browser, and right click it and create a material instance. And then we're going to take this material instance and going to assign it as the landscape material. Then we're going to go back into landscape mode, and we need to assign some layer info to all these layers here. So just click weight blended, press save, and do this for all of the layers here. So our base layer is the dried leaves layer. So I'm going to drag the textures in here. Then for our cliffs, I'm going to take the mossy rock. And for the grassland, I'm going to take the wild grass. Cool. Save the material instance, and now you already see that the base layer is applied on the whole landscape. Now what we're going to do is apply some masks that I prepared for you in Houdini together with the height field to create some variation on this landscape, to actually try out this technique for sampling different kinds of ground types and deciding which kind of static meshes to spawn on it. And of course, with a more complex landscape material, you would automatically create the slope textures, and you would also have some breakups in the texture tiling, etc. But as this tutorial is not about landscape materials, I'm going to leave it like this, and also it's going to be covered by all the assets, so it won't be as visible as it is now. Let's right click a layer and then click import from from File, and then tick all these boxes here and select the layers or the masks that you would like to import. So for base, we're gonna take the terrain base. For the grassland, the terrain grass, and for the cliffs, the terrain cliffs. And then just press import. As you can see now, we have some grassland here in the middle of the landscape, and then the rest of the landscape is mostly this forest ground here with the dried leaves. But then we also have all the slopes masked out and apply this cliff texture to it. And now we're going to use this texture information and apply it in the PCG framework. So let's create a PCG volume. Put it here in the middle of the landscape. And also create a PCG graph asset. And assign it to the PCG volume. And then change the input type to landscape. And press generate. So in the PCG graph, we are going to start with the surface sampler. Increase the density. And now we're going to learn a new debugging technique. So in order to really see what's going on in your point cloud and what kind of information you have on each of these points, you can select a debug object here. And then you press A on the node that you would like to debug. And what that does is it opens up this sort of geometry spreadsheet where you can see all the point information and you can see what kind of attributes are available on each of your points that you're sampling on the landscape. So we can see, for example, the actual density values, etc., etc. And what we are actually interested right now is these three rows here: base, grassland, and cliffs. So as you can see, we are already receiving from our landscape material the layer infos onto our points. So we see it in this data spreadsheet here, but it doesn't actually seem to be visible in our actual point cloud that we are seeing on the landscape. So in order to actually use this data for our PCG graph and to do something useful like static mesh spawning, we need to use a node that's called point filter. And in here, we need to set up a few parameters. So under target attribute, we're gonna set grassland. And actually, you don't need a $sign in front of it because the $, I think, is just for actual point attributes. So since this is a landscape attribute, it's just gonna go like grassland. And then we're gonna receive a warning. And this warning says cannot broadcast threshold type to target type. And this is because we actually want to use a constant threshold here and also set it to float. So what this does now is filter the points by target attribute grassland and only let through points that are larger, because this is the operator that is selected, than the float value 0. So every point with the grassland attribute larger than 0 will pass through the filter right now. And this will make a lot more sense when we put this into debugging here, so we will actually see what's going on here. So to actually visualize what's going on here on the landscape, we need to copy around some attributes. Because right now, all you're seeing is still the default density of the points that's being randomly assigned by the surface sampler node. So after the point filter, we're gonna add a attribute operation node. And we're gonna copy the input attribute that's called grassland to the output attribute density, $density. And then debug it. Turn off this debugging. And now you can see that every point that has a grassland attribute of 1 will appear white, and if the grassland attribute is smaller than 1, it will be gray or black at 0. And to visualize this, I'm going to move this around here a bit, this volume. Since we only have the grassland here in the middle of the landscape, it should be completely black here. And these points here right now are disappearing because our operator is set to larger than. But if we set it to larger or equal, then we will also see the 0 points on our landscape, the points that have an attribute of 0 in this particular sample point. So if we move this around here now, we will see that here our grassland is fading in, and on the slopes, of course, we don't have the grassland. Can also make this a bit more visible by changing the point extents to something like this maybe. So like this, we can dynamically sample weight blended attributes of landscape layers. And now we can use this information and apply certain static meshes to it, or continue with some further filtering, or do all sorts of interesting things. So let's start by actually putting some static meshes on this grassland. So I'm going to add a static mesh spawner. And I'm going to select some wild grass static meshes first. And then turn off the debugging and have a look here. Everything looks really uniform right now, so we're going to add some variation with the transform points node. I'm going to apply some random scale and also some random rotation, as well as some offset, just to break it up a bit. From -50 to 50 on both X and Y. I think we have some couple of issues here. So first of all, it seems to be way too big, the grass, unless you are into this kind of look for some stylized environment. And secondly, we have some strange collisions going on here. In order to fix the collisions, you can go into the static mesh spawner, and under collision preset, you can select the no collisions property and repeat this for all of the meshes. And then if you test the scene again, the collisions are fixed. But now we also want to adjust the scale. Now what I'm noticing is that one of these assets here is way bigger than the others, and we might want to fix this to adjust the overall look. So I'm going to try to find out which one it is. And for this, I'm going to go into the mesh entries and set the weights to 0 to find out which one it is. So the weights parameter is a way to define how often the mesh that you're currently seeing is spawned in your point cloud randomly. So if I have a weight of 1 and another asset has a weight of 2, then that means that this asset here would get spawned twice as much as the asset with a weight of 1. Now I'm just going to add additional assets from this asset pack, the cotton grass. And now what we also want to do is to make it way more dense, to fix this empty space here between the grass. And this is starting to look better. And I would like to add some variation here in the foliage, so I'm going to add a few more static meshes here. I'm going to add some herbs in here. Now I added a few more static meshes, and I'm noticing now that I'm not really happy with the distribution of the static ashes. For example, these European spindle assets here, they seem to appear way too often, and it just looks very unnatural. So what I would like to do is adjust it a bit by setting up the weights of this static mesh spawner. Weights are integer values, so you cannot just like put the weight of the European spindle asset here to 0.1, which is what I would prefer, but actually you have to increase the weights of your other static meshes. So what I'm going to do is unfold everything here and just going to increase the weight of our base grass to, let's say, 5. And now you can already see that you're breaking up the pattern here a bit and it looks a bit more natural. But what we're going to do is we're going to go into the wild grass. We're going to go into the material, and under Enable Grass Wind, we're going to tick this box. So as you can see now, you have some wind vertex animation going on here, and it looks a bit more natural. For the trees, I'm going to take all of these nodes here and just copy them for now. Connect it. And let's debug this surface sampler. Let's turn off the other one here for now, and also this one. And let's change the seed of the surface sampler. For the trees, I would like to use the European Hornbeam package from Megascans, which I'm also going to link in the video description. And to prepare this scene, let's make them all Nanite enabled. So select them all, right click, go to Nanite and enable it. And yeah, make also sure that Nanite is enabled in your project under project settings. And on the surface sampler, we're gonna decrease the points a lot. And we're also gonna increase the points extents to, let's say, 25 by 25. And we're gonna increase the looseness, because since it's like an open grassland, I really just would like to spawn a pretty open field of trees, and then later in the forest areas we're gonna have a denser forest. So let's go into the static mesh spawner and add some of these trees here. Let's debug the transform points here, and as we can see, the bounds are not really matching the trees, so I'm gonna add a bounds modifier before the transform points and just try to roughly match the shape of the trees. 3 by 3 and 5. And let's also turn off the offset for the trees here, because we don't really need it. And then I want to further decrease the density by increasing the looseness. And let's turn on the grass and see how that looks. For now, I think this is pretty close to what I wanted to achieve for this grassland sort of field-like environment. And now we're gonna have a look at the forest environment. So for this, we're gonna copy all of these nodes here. And in the point filter, we're actually going to filter by the target attribute base, because this is our attribute for the forest ground. Connect it and debug it. And then in the attribute operation, we also need to copy from input source base to density. I'm going to turn off the spawning for now. And now I'm going to extend the PCG volume. After extending it and moving it around a bit, I want to check the look here, and actually I think it's a bit too dense already, but we can adjust this later on. For now I just want to see if we can get the points of the forest ground here. I'm here in a spot where we have a transition from the grassland to the forest. And now if we open up this graph and debug the attribute operation that is already set to input source base, then we can see that we already get some points here with a density of 1, so which basically have the base attribute available with the density of 1. And for now I'm going to turn off the static mesh spawner to make it a bit more visible. And I would like to use these points to spawn a denser forest of trees here. So I'm going to increase the points density and decrease the looseness. And then in the point filter, I'm actually going to turn it from operator greater and equal to just greater. And what this changes is that points with a density of 0 are actually being filtered out. And I want to increase this threshold value a bit more to filter out points under a density of 0.2 maybe, or even 0.5. So that we only really get points that are fully on the forest ground. And then let's start spawning some meshes on these points. And here I'm going to use the forest trees. I'm just going to put a bunch in here to create variation. And then let's see what's going on here by enabling them and also enabling the other trees from the grassland. I just want to have a look at the density and possibly adjust it. So the look that I would like to achieve is that it's way denser in the forest and then opening up to these grasslands. But I think right now the grasslands are still a bit too dense. I mean, we see some slight opening up here, but I think I want to make this effect a bit more exaggerated. So I'm going to increase the looseness of the trees in the grassland. So we come from the forest and then to a more open field. Yeah, I think that's better. Then same here, I would like to adjust the bounds. So I'm gonna debug it, and these trees are a bit slimmer than the field trees. So I'm just gonna decrease it here. And then let's also offset them a bit on the z-axis. So I'm gonna transform them and put an offset between -30 and -10 maybe. Just as a side note, sometimes the project crashes. I don't know if it's due to the PCG framework still being experimental or due to other things. And then when I reopened it, it restarted like this and the landscape layers seemed all messed up and I don't really know what causes it. But what I did to fix it is re-import the masks on the landscape. So I go into the landscape mode under paint, and I'm going to clear the paint layers on the right edit layer, and then right click, go again to import and select all these masks. Now you also need to select the height map file, otherwise the import resolution will be marked as invalid and it will throw an error, etc. So select the height map file again, but after selecting it, just deselect it and import the masks. And also import them on the layer masks edit layer. So for me, this fixes these errors. I hope it will fix it for you as well. Okay, so before we start working on the forest floor, I actually want to address this issue here of this hard edge where the grassland biome starts. And I don't really like the look of it, so I will try to fix it a bit. So in the PCG graph, I'm going to turn off everything for now except the grass, or even the grass, and just put it into debug. So now we're going to create a density filter to actually filter out the points that are near the edge of the grassland. So I'm going to put the lower bound to 0 and the upper bound to something like 0.25. And then I'm going to use a density noise after to apply some random density to these filtered points, and then another density filter to remove some of these points. And then to bring back the other points that we filtered out, I'm just gonna copy this filter here and press invert. And then what we need is a union node. So just plug in the two nodes here and it will automatically combine it. Now, as you can see, you still have a pretty harsh border here, so it's not an ideal solution. But if we turn on the static mesh renderer here now, then we will see that it looks slightly more natural like this. So we have some sort of fading effect going on here. And I'm sure there are better solutions for this, but this is something that I could come up with right now. I think it's probably a good moment to organize the node tree a bit here. So I'm going to try to tidy up a bit. Select some of the nodes that you want to group or put into a comment box and press C. So this was our grassland, grass. These were the grassland trees. Then we have the forest trees. And next we're gonna add the forest ground. And we're just gonna copy all of these here. And then let's set the density. I also want to add some grass here, but less dense as compared to the grasslands, and then fill it up more with some other kind of foliage. So for now I'm going to put it to something like 1, and the point extends maybe to 10. And I'm going to add some wild grass and a couple of other plants. Okay, fast forward, so you can just get creative yourself and decide which assets you want to use here. For me, it was just important to create a different look here than in the grasslands. Actually, this might be a good moment to also import the global foliage actor from the Megascan's Hornbeam package. So for this, you need to go into the folder that's called MS Presets, and then just create a filter for blueprint class. Then you have it here on the side, and then this actor will pop up. Just drag it somewhere in the scene. Doesn't matter where. And what you can do with this is you can set the wind noise and the wind strength. What you can also do here is apply some season coloring, as you can see here. I'm going to put it back to where it was. So let's make the forest ground a little bit more interesting here. I'm just going to copy these nodes, connect it. And in this case, we also need a bounce modifier because we want to also add a difference modifier to start subtracting out some trees from the bushes. And then a difference before the static mesh spawner. Okay, way too many points, so I'm just gonna change some settings here in the surface sampler. Maybe try the looseness first, put it on 10. And that's still too many, so gonna try 30 or something. And let's have a look at the bounds. It doesn't need to be super precise. I just want to make sure that the bounds cover roughly all the bush assets, so we can then properly filter out the trees with the difference node. Let's actually turn off the other assets for now to make it more visible what we're doing here right now. And then let's just turn back on the trees and check where we have some intersections, like here, for example, or here. And now we're just gonna put the trees right before the static mesh spawner into the difference of the bushes, and also set the density function to binary. Starting to look a bit more interesting here, so now we can also add some fallen trees and stuff. So I'm just gonna copy all of these nodes here. Also the static mesh spawner already. In this static mesh spawner, I'm just going to use these two assets here for now because they kind of have similar bounds. And then we will have no problem setting up the differences. And then let's also add the trees here to the difference. And let's check that it's also set to binary. Okay. And now we can play with the looseness and see how many of them we want to spawn in this area. Can also have a look from the third person here and see how it feels kind of in game. And after this, I would just like to add some tree stumps here to this forest ground. These two here. So I just copied what we did for the fallen trees here. Okay, now that we have these two sort of biomes, the forest ground and the grasslands, I would like to organize everything a little bit and move it into different subgraphs, since we're going to add a lot more complexity in this scene, and it's useful to utilize subgraphs in PCGs. So in order to do so, I'm going to create two new subgraphs for now. PCG forest and PCG grassland. The graph that we've been using so far will be our parent graph that will hold all the subgraphs. So right now we will clean up here a bit. Let's open the grasslands also. And then just gonna move over all of the grassland nodes. Copy them. All right, so what we need to do in order for this to work is connect the input node here to all the surface samplers. So I'm going to do this and jump back into the parent graph and delete the grassland nodes here, and then just drag in the subgraph and also connect it to the main input node here. So now all the logic for our grasslands is in its own subgraph, and we're going to do the same with the forest. So let's open up the forest graph and repeat the process. And then let's make sure again to connect the input node to the surface samplers. And now we're going to also tidy up here a bit. This was the these were the bushes. Then we have the large fallen trees. And the tree stumps. Then I'm jumping into the parent graph again, delete all the nodes that we copied over, and drag in the subgraph of the forest here. And then everything should work again. So this is a really neat way of staying organized, and now you can just like press E on the grasslands and it will not calculate the grasslands. And yeah, you can just work very comfortably in more complex kind of PCG setups. So let's start working on the slopes. I'm going to create a new PCG graph that I'm calling PCG slopes, and already drag it into our main graph, connect it, turn off these two for now, and just jump into the slopes graph. We just start with the same setup to filter out the weight data from the landscape layer. And under point filter, we're going to put cliffs. Same goes for attribute operation. And then I'm just going to debug it. And I'm going to adjust the surface sampler a bit. For now, I want to have a ton of points to see what's going on. So just going to increase everything here. Let me actually go in the landscape material and make the slopes a bit more visible here. So I'm going to go in the texture for the slopes. And I'm going to decrease the saturation a bit. So what we can see now is that towards the edges of our slope, the density of the sampled points is approaching 0. So it's like barely visible right now, but as you can see here in the middle of the slope, the points are brighter than on the outside of the slope. And now we can use this fact that the slopes are fading out due to our weights on the landscape to our advantage to create a sort of gradient of density that has then bigger cliffs in the middle of the slope and kind of like a faded out scaling towards the edge of the slope. We need 2 density filters. Let's first check one here and adjust the parameters. So I'm going to debug it and see what happens. So first I want to filter out the points that are on the edges of the slope, something like this. And now we also need the exact inverse of this filter. And for this, we can just copy the filter and press invert filter and then check what's going on in the debugging. So what we have now is these points on the edge and the points towards the middle of the slope. Now what we can do is we can create a gradient using the distance node and using the points that are on the inside of the slope as the source. So I'm actually going to put them up here. And our edge points as a target. And then also checking the set density flag here. The maximum distance is right now set to 2000, which seems to be way too high. So let's try something like 500. And we should already see some effect here. So now what we can do with this is add a node that's called execute blueprint. And then you have a few preset blueprints here that Epic Games provides, but you can also create your own. And I'm just going to look for density, scale by density. And don't forget to change the scale min and scale max. So maybe we want to scale from 0.1 to 1, or maybe 0.5 to 1.5. And as you can see now, these points towards the lower sides and upper sides of the slope are smaller than the points in the middle of the slope. Now, the thing is, everything is pretty hard coded here right now, sort of, because what if we want to change the lower or upper bound here? It's not very comfortable that we have to change it in 2 places. And that's why we could introduce a variable here for these lower and upper bounds. So we only need to change it once if we need to. So in order to set up variables in PCG graphs, you just need to go into your parent graph and click the graph settings. And then under instance, you create a new variable. In this case, we would like to have a float variable. Let's call it slope lower bound and slope upper bound. And let's default it to something useful like these values here. So now what you can do is to get these variables in your slopes node, in your slopes graph, is that you go into this graph, and on the input node, you can create a custom pin. And we're going to create one for the lower bound and one for the upper bound. And then we're just going to unfold this little arrow here on the density filters. And we're just going to assign the lower bound and upper bound in both of the nodes. Remember, this one was just like the inverse of this one. So I just did this for convenience in case we have to change these lower bounds. And we can do so now. If we save everything, then we can change it from the PCG volume under PCG component. And then you see here the variables that we just created, and we can change it. So next we want to filter these points and spawn different glyph assets on them. So I'm going to create a density noise to create random density values now on these points here. And then use a density filter. And a static mesh spawner. And also a bounce modifier in between. Let's add the first rock asset here. And let's see how it looks. Next, we need a transform points to change everything up here a bit and adjust the scales. But first I'm going to deactivate it and actually work on the bounds of this rock asset. We will be using different bounds per rock asset because I want to be able to spawn foliage assets in the gaps in between the rocks. And then I'm just going to repeat this process for the other rock assets. And here the scale mode of the bounce modifier is not yet giving us the best results. So I'm going to add another bounce modifier after that, which I'm going to set to translate. And then just move things around here a bit. So let's turn everything on and adjust the look of this slope here a bit by changing the transform points. I think these ones here can be a bit bigger. And then I just changed around some settings in the surface sampler to adjust the point density, and also went back into the scale by density to make the point scaling towards the middle of the slope a bit more exaggerated. And it started to look like this. So now what I would like to do is fill up these gaps here with foliage. This is going to be a relatively simple setup. Just going to start from this point here again and connect these nodes. And then just increase the amount of points. Next, we need a difference node and a static mesh spawner. The difference is set to binary. And we also want to transform the points a bit. And then assign some foliage assets. So right now the foliage assets are spawned all over the slope, and now we're going to filter out the rocks from the generation of the foliage assets. For this, I'm going to create a union node here, and I'm going to plug in all of the transform points from each of the rock assets. And then I'm going to connect it to the differences here and let it calculate. Thanks for watching. I hope you learned something. And in the third part of this tutorial, we will create a lake, a procedural pathway through the forest, and another example of a mesh sampler PCG graph, a dead tree with vines growing over it and mossy patches, etc. So see you in the next part.